If it's difficult to get. Okay, so good afternoon, everybody. Welcome to this session. Risk management techniques is the heading, and on Sunday we had looked at the hazard and operability study. We had looked at the hazard, right? We looked at advanced techniques. We even went all the way back to normal risk assessments, right? The 5x5 matrix that was actually shown in your textbook as well. Again, let me just try to pull a picture up for you also. The big 5x5 matrix was shown in the book as well. So nothing wrong with that, but we had to kind of work our way up to advanced techniques, and that is where we are at right now. Taking it straight from here, we're going to do at the bow tie analysis technique, and let's have a look at that one straight away, right? And we'll see how this goes. So, um, I would have liked to ask if you all remember anything about the hazard, though. Was there anything about the hazard that you all, you know, particularly remember? Like when was it used? Like when is a hazard used?
in the um in the in the initial stage. I
Right, in the
remember the
initial stages.
GDPCA more. I remember the GDPCA more than anything though.
Right, okay, very good. I told you that.
After that was cool. Yeah.
Yeah, man, up to today I was walking and I remember, um, just give me a minute. I'm trying to, yeah, just walking. I remember it. I remember in GDP and it's like, what does that stand for, right? Um, yeah, but so it is anyway, right? So it is a thing with acronyms anyway, right? Just 1 minute, just replying to, um, right, anyway. Okay, so we have this technique, right? If you want, those of us in the book, you can check page 32, in fact, right? 32. I think we mentioned the Swiss cheese model already. We did that one on Sunday, right? So taking it from here, the bow tie method is a risk evaluation method that can be used to analyze and demonstrate causal relationship in high-risk scenarios. The method takes its name from the shape of the diagram that you create, which looks like a man's bow tie. The bow tie gives a visual summary of all plausible accident scenarios that could exist around a certain hazard. Second, by identifying control measures, the bow tie displays what a company does to control those scenarios. So let me just read a couple more and explain, right? The left-hand side of the bow tie describe how events and circumstances can release a hazard, which, dependent upon the effectiveness of the systems and effect and activities in place. Let me admit somebody here called active control barriers can lead to an undesired event called a top event with the potential for harm to people, assets, or the environment. The right-hand side of the bow tie represents the scenarios that may develop from the undesired event, the consequences, dependent upon the effectiveness of the systems and activities, reactive control barriers. Both ties have the advantage of being a clear graphical representation of what can sometimes be complex or a complex safety system. They show clear links in safety and management systems. Active barriers are put in place to prevent a hazard from causing the top event, and reactive barriers are put in place to reduce the consequences. Each barrier relies on one or more activities carried out by an organization, such as design, engineering, or operations to ensure its presence and effectiveness. Barriers can be hard, such as fire, explosion, wall design, or soft, such as procedures and individual competencies. So we can explain it, right? So basically, if you look at this chart, a bow tie is a cause and effect diagram. You can see that, like on the left-hand side, they have the causes. That's all they were talking about, left and right-hand side. So if you have like, we could just change this a bit if you want to something that you're familiar with, like a chemical spill, a fire. A fire could be like something everybody could relate to. And with the bow tie, like on the left-hand side, and they'll have all the causes of the fire, right? So you could think about smoking is the cause of a fire. Things like flammable atmospheres, whatever you're accustomed with, right? Like maybe high amount of combustibles being stored on the premises. So um, some sort of static electricity, some sort of electrical fault, all of these things could be the causes of a fire. So all the causes are shown to the left-hand side. And when they talk about barriers, the barriers are these things here, right? So like if you identify smoking as the cause of a fire, then these things that you were saying, these barriers could be hard or soft. So hard could have been like, like a control is a designated smoking area. So that's something physical. And so they said that's a hard barrier, right? But a control could also be like a no smoking policy. So then the controls could be hard or soft because a policy is a document. You think you understand that a bit? And so the more of these you have, though, because you only have one here, but you can put more than one. The more barriers you have, the less likely that the fire would happen because of that cause, right? So if we said faulty electrical, a barrier here could have been regular inspection. Another barrier could have been purchasing good quality components, right? Another barrier again could have probably been, like something called I don't know if you know this one. It probably wouldn't because it's something in the UK, but something called PAT testing, PAT, right? Part testing, PAT, portable appliance tool is like something from a law in the UK that require a tool to be tested 3 times or 3 folds of testing. So if you say something is part tested, it would have been really tested. It would have been tested by safety, by a competent person, by electrician. So a part testing is a really good examination and testing, right? So if something was tested that often, the chances are less likely something would be faulty, there'd be some wire somewhere exposed because it would have gone through a rigorous testing regime then, right? So those are the causes and the barriers. These sort of things you're seeing here represent what could stop the fire from occurring, right? However, the bow tie doesn't only have one side. This is so-called the left-hand side, the causes. The bow tie also considers what if? What if we have a fire? So what if we have an influx of hydrogen? You have a blowout, injury to personnel, damage to safety critical systems. So what if you have a fire? You could have property damage. You could have, damage to equipment. You could have injuries. You could have death. And what the bow tie also does, it comes up with a reactive plan. So on the right hand side, they say the plan is active. They say the plan is active or proactive. And on the left hand side, the plan is reactive, right? But even if it's reactive, you are being prepared then. So, like if there is a blowout, what this barrier represents, or these barriers, is how they will deal with the blowout. You see, they say here mitigation barriers. Mitigation means control. So, if there's a blowout, how they will deal with it. They still have a plan, right? Firstly, the plan is proactive to prevent it. But if it does happen, the bow tie captures the consequences. And and so forth then, right? So the consequences have a plan, right? So look at this one, environmental damage, but they have a plan. So the plan may be informing the EMA, the plan may be some sort of spill prevention team that comes by, the plan may be dealing with members of the public. They still have a plan, they have like a contingency plan, right? That's a good way to think about this, right? So the left-hand side is proactive, the left-hand side is proactive, but the right-hand side considers what if we have a negative event? How do we deal with it? Do we run around? Do we run around now with, screaming to the top of our lungs that, the building is on fire? Yes, it burned, but did you have insurance? So like the plan is that if there's a fire, you have insurance. The plan is if there was a fire, we have another base. We could operate from home. We could rent another office. That's plan B, right? So think about it like that. I don't know if they'll ever ask you because this is such a nice question. If they were to ever say, describe the bow tie analysis, hopefully you understand part of what we said here. And you can be able to put it back in words. Like the bow tie is both proactive and reactive. It considers how to prevent an accident, but also if the accident does happen, we have a plan. We have plan B. That's a good way to think about the right-hand side. Plan B, right? Tell me what you think. You think you understand it a bit? The thing though, what I was saying to you all is like, unlike those who did process safety, you all may actually have to construct one, right? So construct one is very simple. You just draw a circle with a ruler, of course. I mean, this straight line here, this supposed to be with a ruler, and you come like this, and then you go up like this, right? And then, I mean, basically, this is whatever you want to prevent the fire. If it's that, on the left-hand side, you would consider all of the causes of the fire. On the right-hand side, you consider property damage, injuries, and how you'd still deal with it, right? So you connect it with a broken line, and then you start to see the shape of the boat. I think that could be sufficient for 4 marks. I'm not sure, right? I haven't really seen any bow tie questions where they ask you to draw. But then, I possibly, we just have a couple of pacifists, to be honest, during the pandemic. They have not really, this course is not available in the region, so we haven't had any pacifists since then, right? But it's a nice thing to learn anyway. And, I could foresee something like that coming for you all, right? A nice 4 mark question there anyway. Moving on. So we skip that one, we skip that one. So I think they have ETAs. I saw ETAs very briefly in your book, so I'll also touch it very briefly as well. So I'll just read and explain, right? Because I didn't see too much ETAs in your book. But I think I was saying Sunday, an ETA is like a quantitative way to do one of these risk assessments, and it's one of the good ways to do a risk assessment. If you look at page 11 or 21, well, if you look back at the slide, you see there are different types of risk assessments. You have qualitative and you have quantitative. And this one here is a quantitative. Quantitative risk assessments are better. If you look at the heading here, right? Quantitative risk assessments are more objective and stuff like that. And an ETA falls within that category. But because there's no real emphasis on it, I wouldn't emphasize it too much in the course, right? I'll just read out this slide. So ETA stands for event tree analysis. It's based on binary logic. Event tree analysis provides an inductive approach to reliability assessment as they are constructed using forward logic. ETA is a graphical representation of the logic model that identifies and quantifies the possible outcome following an initiating event. As the number of events increases, the PTA fans out like the branches of a tree. The starting point referred to as the initiating event disrupts normal system operation. The event tree displays the sequence of events involving success and or failures of the system components. So an ETA is like a sideways family tree. The top of the tree shows you so like there's a top and the bottom part of it. The top of it shows you the probability of success, right? And the probability of success that a component actually works, right? So if this was a question, they will give you a component. So on top here means this is the probability that the sprinkler system work and it extinguish the fire. This one here means this is the probability that the call to the fire department work and it extinguish the fire. To the bottom of the chart means the sprinkler system doesn't work and the fire went on. Down here means that the sprinkler system didn't work, but the call to the fire department did work, so there's partial damage. To the bottom of the chart means everything failed. The sprinkler system didn't work. The call to the fire department did not work as well, right? So I don't want to do too much. Like I say, if it's not there in the book, I don't want to do too much, but I wanted to understand it. It's like a sideways family tree. Um, I don't see this is plenty marks, and given the fact that NEBOSH question is worth about 4 marks, 4 marks by 4 marks. I don't see a question like this coming where they tell you to construct an ETA, right? If they do, though, when you hear me say probability, they will give you the figure for here. Like they will say the probability, which I don't foresee, right? They say the probability of the sprinkler system working, they'll give you a figure like 0.2, right? That'll be in the question because you wouldn't be able to dream up your own numbers. The call to the fire department, they will say probably that's like 0.4, right? If they ever ask though, so I don't know if you want to take this long, if they ever ask to calculate the probability of success, what you have to do is multiply these figures to the top here. Yeah, they multiply 0.2 by 0.4, which this is kind of treading the degree course now, right? Which is why I don't think, but it's good to know that's how they get the quantitative, when we say, when we say that the ETA is quantitative, right? That's how they get to be quantitative then, right? To get the probability of success. So just put S here, you multiply all the figures on top. So it would have been 0.2 by 0.4, right? 0.2 by 0.4. To get the probability of failure, it's a very long calculation, and that's like 20 marks. And seeing that NEBOSH Oil and Gas doesn't go for so much of marks, I don't think I'll show you the formula for the probability of success. It's a very long formula. Each line takes up like a whole page anyway, right? So seeing that this is not here, like I said, I think I've done it to prove the point that there are quantitative risk assessments and that these types of risk assessments does occur. It's pure maths then, point two by point four, right? And I think we can move on to something else anyway, right? So there's one called failure mode effect analysis. If you want, I could just read one side and explain. I didn't see too much of this either in the course, but this is yet another example of another advanced technique. So failure mode effect analysis evaluate the ways equipment can fail and the effects these failure can have. In an FMEA, each individual failure is considered as as an independent occurrence with no relation to other failures in the system, except for the subsequent effect the original failure may produce. FMEAs identify single failure modes that either directly result in or contribute significantly to an accident. So to explain that, the answer is right there, but it's for us to zoom down on it, right? Let me just try to clean this slide a bit. So what an FMEA is and how it differs from like the other type of assessment is that the FMEA considers the effect of a failure of a single component, right? You'll see that here, right? So FMEAs identify single failure mode. So just to make it simple, right? Of course, it's not always simple because you have generators, you have pumps, and you have, centrifuges and stuff in the field, right? In the oil field, right? But there must be a part of it that if that part fails, that is like a critical part then, right? And an FMEA will consider like what is the failure of a component on the entire system. So to kind of bring it down, like to something common around your everyday equipment, and you could consider like your car then, right? So you have the best of vehicles and whatever have you, but the alternator is not working. So a failure mode effect analysis will consider what if the alternator is not working. You just put a new battery, but the alternator is not working, right? The other part of that is like we could even consider your phone. So the best of phones again, the best of phones, right? But the battery not taking charge, right? In that sense, you could consider an FMEA study is a study of a component. So if the charge port is not working, well, then how do you get on to use that phone then, right? So you see it here, break the system down into components, determine how each component may fail, determine the possible effects of these modes of failure, consider how each failure mode can be detected, assess the consequences of the failure on the system or other components, right? And I had one here. Again, these things are big marks at the degree level. I don't, foresee you all getting any one of these things to do anyway, right? With an FMEA, they also calculate something called the risk priority number. They get that by multiplying the severity times the occurrence. They will give you those things. If that was a question, they'll tell you the severity is 4, the occurrence is 2, the level of detection is 1, right? And if you multiply those, you get the risk priority number, right? So FMEA failures are prioritized according to how serious the consequences are, how frequently they occur, and how easily they can be detected. FMEA is used during the design stage with an aim to avoid future failures. Later, it is used for process control before and during ongoing operation of the process. Ideally, FMEA begins during the earliest conceptual stages of design and continues throughout the life of the product itself, right? Those types of studies, the FMEA, the HAZUP, and the BOTI, all of those kind of studies are called what-if studies. In a what-if study, nothing has really happened, right? Like that's what we say now, like the component didn't really fail. We consider what if, right? In the BOTI, we kind of consider like what could cause a fire. It's still like what if. In the HAZUP, if I go back here, you'd say we still consider, like, would the temperature increase? They would say more. But the truth is the temperature didn't really increase. It's just like a what if analysis. Oh, by the way, can you all see the PowerPoint in the background? Yeah? Because the last class you all didn't see it. Can you all see the PowerPoint in the background?
Yes,
Yes,
sir.
sir.
Yeah, we've
Great.
seen it. Yeah.
So, okay, good. Right? All right, next thing I see, we had gotten almost half an hour, nobody said anything. Okay, so that's finished. And if you look at the book, which you don't have, the thing is, there's
Professor,
a question. Sorry, go ahead. Yeah, for those
No,
who
the
have
reason I'm not saying anything is because I'm clocking into work right now, so I'll just be listening.
not a problem, Nikisha, right? Nikisha across in Guyana. All right. So I think we could come back to this because there's something else here to do, right? And then we could come back to that. So if you look at your book for those who have it, if you don't have it, just look at this slide, right? So one of the things is a very famous question is this, the concept of ALARP. Don't know if you can see that anyway. The concept of ALARP, as low as is reasonably practicable, right? So what is that all about? And so there's a past paper on it. They look at only it comes to exam. Then so look at here, right? So if you want, let me read two slides and then I'll explain. I don't know if it makes sense. But maybe this bit here makes sense, right? So what is ALARP? Of course, it stands for as low as is reasonably practicable. What that basically means is that a company has to spend money to reduce the risk, right? Because this is the oil and gas field, right? So if you think about somebody getting into a tank, somebody getting into a vessel, the company have to spend money, right? It's not as if they can say, look, okay, like we don't have money to get the tank purged. No, you have to spend money, right? Or they saying, okay, like we don't have money to hire a fire watch or a whole watch. No, you have to spend money, right? However, if you look at what as low as is reasonably practicable means, if you look at this chart, it means in some way it is still reasonable. The cost to the company then is moderate. You understand? It's not too expensive. See if you see it here. As low as is reasonably practicable is point A. Point B is if the law had said, because as low as is reasonably practicable is a phrase from the law, is if the law had said reduce the risk to zero. But the law never said that. The law said reduce it sort of based on the company's money, sort of based on the company's time, sort of based on the company's effort, right? So you are spending money, and in a way, I mean, like a way to describe this, like you're spending money that would hurt your pocket. Yes, it would. It would hurt your pocket a bit, but you're not going broke. The company is not going to go broke for hiring, a competent company to come and do gas testing. They're not going to go broke for that. But it will be a little bit more than. So it kind of like pain in you to spend this money because as I say, go as low as you could then, right? So go as low as you could. So it may be hurting you a bit. Like the company you're talking about, to pay for all of these workers, you have to be trained in firewatch. I'm just making up something, right? Or all the workers to be trained in, well, workers to be trained in something, right? Or hire in a company to be like an emergency rescue team, right? With rope rescue and equipment and stretcher, and it may cost because initially, like the company would have said, we just have our safety be the first aider, but no, this is tank entry or this is vessel entry. So you need the ambulance service. So you need like a private company there. Then. So it hurts you to spend the money, but you're not going to go broke, right? So see if you understand. So that's why, so they didn't say the risk was low. Are you all seeing that? They didn't say it's not going to cost the company nothing. They didn't say it's going to cost you where you could dig in your pocket or dip in your pocket and it not hurting you. It hurting you. It hurting you to spend the money in terms of the company. Go as low as you could. But you don't have to do everything. You don't have to really put your company on the breadline then to find a lot of money. It's not going to be too expensive. That's why the word they say here is what? What's this word? This word is what? This word
Reasonable.
reasonable, right? Reasonable. Now, what they like for exam is a phrase, right? I'll just go ahead and tell you the phrase, right? But I scan in the book to see if I see it, right? Yeah, I see it, I see it. I see it, right? What do you like for exam? You have to tie, if you're going to talk about reasonably practicable, you have to mention that the only way the employer could get away from not spending, and this is a kind of crazy phrase, right? The only way the employer could get away from not spending a lot of money is if they can prove, so this is the words they're looking for, that the cost would be grossly disproportionate. This is also in your book. That's what they look for, right? This is in the book, page 27, grossly disproportionate. So the cost is not grossly disproportionate to reducing the risk. So ALARP means reducing the risk. If you want to learn, remember this is a learn exam, right? So it says about weighing up the risk against the sacrifice needed to reduce the risk in terms of cost, time, and money. It's a moderate cost. However, the employer could avoid having to pay the money if they could argue that the cost they have to spend is disproportionate to the benefit of the risk or grossly disproportionate. So those are two words you have to put in your vocabulary then. You have to learn that grossly disproportionate. What does it mean? It means, I could probably use a household example. It means like, okay, like you want to buy something, right? Whatever you want to buy, watch, phone, whatever have you, right? You want to buy something, right? But the one you have seen is normal price. But then there's another one that's like 10 times that price, right? So you could say, well, I can't buy this one that is 10 times this one. Could seem to be the same make, whatever. Just the brand is different, right? And then you can say, tell yourself to spend 10 times the money on this one is going to be grossly disproportional then. It's a gross cost. It's like too expensive, right? So that's what the employer will say. The employer can say they can avoid having to spend money if they can say that to spend this amount of money is too much. In other words, and it gets in the expensive range, if you go back to the graph, right? Then they can get away by saying, look, this money is too expensive. And what I'm saying is that they cannot make stuff up. Like you cannot say the price of training is too expensive. No, it's not meant for that. It really is something that have to be too expensive, right? So I think I was telling the process safety class on Sunday. Like an example for this is if they were doing tank cleaning and somebody recommend, well, let's use robots, let's use drones and robots. And so that's a perfect example because in a way that's not reasonable. Now we could probably use drones and robots, but what's the cost? And if the cost is too expensive, that's what the employer can say. The employer can say, look, I have already done, first aid training. I have already done, like a whole watch training with the workers. I've done gas testing. I have the emergency rescue team. I have the ambulance standing by. We have done a risk assessment. We have done a permit to work. So to go into robotics now, folks, you think you understand it? So to go into robotics now would be too expensive. That is the meaning of as low as is reasonably practical. But you do what you can do, but you don't spend a grossly disproportional amount to reduce the risk. And it have to be that. It have to be grossly disproportional. You understand that? So the robotics example is a very good example. I don't know if you want to take it down. If they ask you to describe what is ALARP, you can talk about the employer will spend what they could spend, what is reasonable. Look at the graph, what is reasonable. But to do something, even if that form of technology exists, right? To do something in the region Trinidad, Guyana that involves robotics and the cost that come with that may be seen to be too expensive. In that case, the employer does not have to. You just have to do what is reasonable. Do the gas testing, purge the tank, have the rescue team, and that itself is expensive because it never said it was a low cost. It said it was a moderate cost, right? Tell me what you think. I think, like I said, I mean, in every paper, there is something like this. Look, there is one. We passed this one, right? Look, there's one here. Let's have a read of it, right? So I don't want to spend too long in it, too. I want to keep on teaching, right? So concepts and commissioning, process plan, project phases where risk management applies. Identify 4 additional projects. I think we did that on Sunday. It's on this slide, by the way, right? 4 additional project phases where risk management applies. Part B, outline the concept of as low as is reasonably practicable within risk management. 2 marks. So in your 2 marks, you have to mention the phrase the employer doesn't have to if it's grossly disproportionate, but they have to, right? Spend a moderate amount in terms of reducing the risk associated with a hazard, right? Outline how a quantitative risk assessment differs from a qualitative risk assessment for 2 marks? Anybody remember one of the answers for that? Qualitative uses what?
Qualitative is words and it's descriptive, and quantitative is numbers.
Most, yeah. Is it?
Yes. Which one is more objective?
The quantitative.
Very good, right? Very good. Um, just let me just reply to one message here. Okay, moving on. Let's go again. Very good, very good. If you, by the way, remember because they repeat, a good idea is to do the questions and send it in because they repeat questions, right? 11 questions in a paper, 4 marks. Well, each one is about 8 marks, 4 marks for like part A, 4 marks for part B, right? Um, you know, if that's the case, you could do it and send it, and you could like research it too now, like put it into Google and get the answers and prepare. Get a book, get a book and start to do these things, or get some papers. When you get the corrections, some of you all did them, keep them because you have kind of heads up on NEBOSH. If you do it like that, you have a heads up on them. But if you ignore it, and then when you see it in the paper, you say, well, oh crap, I should have write a definition for as low as it's reasonably practicable. I should have done this. I remember associating it. But if you do it now, like with the written exam, it have a little weakness I told you, which is the repeat questions. A good idea is to do it. Hierarchy of control, right? Let me see if I could just, yeah, I'm seeing this too a bit. Concept of hazard realization, concept of risk control barriers, right? And so let's just mention this one briefly. So the hierarchy of control, many of us know, starts from elimination, substitution, going down the line, engineering controls, administrative control, PPE. The ones at the top, eliminations and stuff, are the highest and the most preferred control measures anyway, right? So it's always best to eliminate. However, that's always a bit more expensive. Things like buying better components and inherent safe process with a low level of danger, even if things go wrong. An inherent safer design is one that avoids hazards instead of controlling them, particularly by reducing the amount of hazardous materials and the number of hazardous operation in a plant, right? So inherent safe design is always about like choosing better components, spending the money up front and making sure that you kind of get rid of the risk at the beginning, right? So this again, straight from the book, we have use of modeling. I'll show you this one from the textbook. My slides may be a little bit better with some of these because I don't have too much of pictures here anyway, right? So modeling is a valuable tool to assist in examining possible major hazard scenarios and is useful in safety, case development, and justification. Modeling software exists for substances which include LNG, LPG, chlorine, and ammonia. And again, like modeling, like where the vapor is going, these things are very good in terms of a risk assessment. If you see examining the possible major hazard scenarios, these could be done with 3D software. A lot of video games and stuff, PlayStation and stuff have better technology than, well, I mean, this slide, but a lot of that technology is actually part of modern calculations anyway, right? So modern and computer-generated predictability can be seen or used for blast zones. Where do you put active and passive fire protection, right? Active fire protection is things like extinguishers. Passive fire protection is like coating these metals here with a fire retardant, right? So like you could do that on a model calculation, see what happens, and then you could implement it in your plan. Where the safe havens, which is a safe place to go in the event of a vapor or some sort of, fire. Citing of safety critical controls, avoid conflicting activities, storage, flaring, drainage, etc. Here we have a gas plume modeling and basically looking to see like where the gas plume is going to affect. And then all of this is going to influence, of course, your hazard preparedness, your hazard prevention, and, lean to things like a better plan than in the event of an emergency. Thermal radiation output blast zones. A number of organizations worldwide conduct LNG fire experiments in the 1970s and 1980s. These tests have included LNG spill tests on hand, contained within a dike and a limited number of water, right? And so a dike is like a collection pool. This is like a potential simulation here that could have said what would have happened to a blast zone anyway. Just let me just take on my camera a bit, right? So some tests show that large fires burn with a production of copious amounts of black smoke or soot. Um, let's see, the effects of smoke is to obscure the inner burning core of the fire, thereby reducing the amount of total radiation that is emitted by the fire. The puffin type of burning are released at a frequency determined by the fire size, right? So again, I would say here maybe the whole grand effect of simulation. We have out here lighter damage, moderate damage. This is just common sense, right? Complete destruction here. We could call it the blast zone or zone zero for those who know that anyway, right? But thermal radiation could actually let you see that. And what happens if there is, like a fire on a tank battery? What happens if there's a fire on a line, right? Some sort of, cooling vessel. So where are you in this sort of blast zone, right? If you look at the heading thermal radiation output blast zones, and you could have a better plan out of that. So like a nice question here is like, what is the uses of thermal radiation? What is the uses of modern calculation? The answers could be endless to identify and predict and foresee potential hazards, to allow for better preparedness and controls to reduce and mitigate those hazards anyway. And you could think of some others. These things, again, typically 2 marks, right, is what you have to put out here anyway, right? This one outline, so another question on ALARP, outline the concept of as low as reasonably practicable, identify two risk control barrier models extensively used in the oil and gas industry. Um, outline the concept of risk control using the barrier model. So part B, right? Part B is identify. Identify doesn't mean to explain. Identify, just so to put it in a sentence, you'd say like a risk control barrier model that is used extensively in the oil and gas industry is the bow tie analysis. Could that have barriers in it, right? Another one, I mean, whichever one you are happy with, right? You could probably go with what's the next one we did today? Failure mode effect analysis, if you want to go to ETAs or whatever have you, right? So that's just an identify question. It isn't really to explain anything. The second piece here, part C, sorry, outline the concept of risk control using barrier models, right? And you could that means you have to talk about them. When you say outline the concept, because you just identified the risk control barriers, you just have to talk about them. Like, what is the bow tie left-hand side cause and effect? What is the right-hand side? You have to kind of talk about them. I could see each of this here. This is 4 marks. You may have to get 2 points on each one. So like 2 points on the hazard, 2 points on the bow tie, which is so much more than 2 points to get at 4 marks. Tell me what you think, right? You think, like I said, the open book exam is a little bit tougher because with the open book exam, you have, more points to generate that, right? What do you all think? What do you all think?
Yeah, put a shot. Yeah,
It is
yeah, just
definitely
had to learn
worth
and
a shot.
remember. Yeah,
Yeah,
yeah.
it is definitely. Yeah, that's the thing. And that's the thing with these exams, right? These exams, you have to kind of start internalizing. I told you how I did it, how we had to do it. We didn't have any books and stuff, right? But even if you have a book, folks, it makes no sense. Look, what class I was talking to? Was the certificate class of a class writing exam, right? Next week. Last time we doing our past paper, right? Policy. For those of us who did the certificate with me, right? So ask them, so like, I don't remember what chapter is policy. Anybody here remember what chapter is policy? With those of us who did the certificate course? But you don't have to, but they have to because they have exam next week, right? So I was saying that to prove to them that they're not even reading their book. So there's one thing about getting a book that's priced at $400 TT, but the next thing is if you're all using it. But you all have to because you all have an open book exam, right? So start committing. That's the good thing is that we kind of know some questions coming. We kind of know like they're going to repeat. So like you have to kind of commit that to memory anyway. And that's the old way of learning. But there's also, I think, the only way to learn is how people remember, right? When you have the open book exam, the downside of the open book exam is that you can't remember nothing. Those of us who probably did the certificate, you probably remember a little bit here, a little bit there, but you don't remember anything, right? Let's go on. I didn't want to stop for no pacifying. Okay, so what I want to do, I wanted to finish. Oh, we're on slide 61. How did we read so far? That's very good, which means I could actually start the other PowerPoint, right? Um, right. So organizational documented evidence of safe to operate. Let me read one or two of that. This is very simple, but let me read one or two of it first, right? An organizational or organizations documented evidence of safe to operate. So there has been a marked shift in regulatory approach to ensuring safety systems or system safety. A lot of laws in the UK, in fact, right, which is said regulatory. Whereas compliance with prospective safety codes and standards was previously the norm, but today is the law, right? That's what we say there. The responsibility has now shifted back onto the developers and operators to construct and present well-reasoned arguments that their systems achieve acceptable levels of safety. Let me see what I can have and explain, right? There's actually a law in the UK for those of us who know the HSW Act, that's Section 6. If you're new here, you haven't done the certificate level, there's a law in the UK. It's called the Health and Safety at Work Act. I write in it here so that nobody's at disadvantage. And it's actually Section 6. The Health and Safety at Work Act, the year is 1974. And those of us who did the certificate course, we never really focused on Section 6, did we? But Section 6 was on your slide. And Section 6 is actually a duty on the manufacturers, right? Section 6 is a duty on the manufacturer. So when they say that here, yes, companies, phone companies, manufacturers of pumps, rods, whatever, there's a duty on them then to make sure that their stuff is properly tested, it's safe, you have a guarantee, you have a warranty on that product, etc. Let's go on, right? Because I don't think that's what the topic is all about, right? We're trying to reach the main thing still. So an organization documented evidence of safe to operate. So these arguments, together with the supporting evidence, are typically referred to as a safety case or a safety report. Now, I've seen some questions on this, right? So the documents to ensure safety then, what it safe to operate is called a safety case or a safety report. A number of serious accidents, such as Piper Alpha disaster and the Longford LNG plant explosion in Australia, have been instrumental in prompting a reconsideration of how safety is managed in the safety critical sector. It is up to the operator to demonstrate that they have an inadequate argument of safety, i.e., that they can demonstrate that an installation is acceptably safe from the evidence available. Let's read on a bit, right? So an organization documented evidence of safe to operate legal. So legal requirement, I mentioned a bunch of laws. I don't quite know if they'll access any of these. We have the UK Offshore Installation Safety Case Regulation 2005. The second one here is very common. The second one here is the Control of Major Accident Prevention Hazard. That is Puma has been updated enough. But you could give the initial year, right? 1999 is the initial year. Nothing is wrong with that. You could give the initial year. The assessment principle for offshore safety cases guide that assessment. The essential principles of offshore case complement the guidance on the regulation. They should be read together, right? The purpose of documented evidence. So what's the purpose in having the report then, saying that you have done your test and everything is safe, right? There's a lot of purposes there. So application for insurance, you could show that whatever you install, if it's a generator, some sort of new equipment, that it is safe, right? Commercial tenders, probably could use it as an accident investigation, as a defense, right? Internally in the organization for training, communication, and consultation with health and safety representatives. in the public domain, for example, when communicating with local community who may be affected by a major accident, it does show compliance with the law. So having the safety report then kind of shows that you did something, you know, to ensure that the safety of the equipment. So in the event of any accident, you have that there waiting to say, okay, look, we tested this generator, we tested this piece of equipment, it was sound, right? You have your safety case kind of put down there, right? And of course, it could be used for compliance, could be used, for insurance, could be used for, I guess, additional tenders. But it could also be used in the events to show consumers, customers that as a company, you did what you had to do. And what happened probably was just a manufacturer's defect, right? Typical contents of documents, safety cases, and safety reports. So there's a major accident prevention policy in place. So that goes in the safety report. The safety management system is adequate to ensure legal compliance. You could think about things like ISO 45001, and that satisfactory arrangements are in place for the management of contractors. All major accident hazards using relevant risk assessment techniques have been identified. All major accident risks have been identified. Typical contents of a documented safety case and safety report. Measures are in place to control major accident risk. Adequate arrangements for audits are in place, and the process for audit reports have been laid out. Adequate emergency plans are in place. You could pick some of this as a safety report. Just probably pick what you think is easy enough for you and kind of learn some of them, right? So like, okay, it have a policy. It have compliance with the management system. All the major hazards have been identified. Risk have been assessed. That's not too hard because that's like all safety things. Think you get it a bit? This could be a question. Why is it like, what are some things in a safety report, a safety case? But some of us could just reason it out. Would it have a risk assessment in it? Yes. Would it have accident prevention in it? Yes. Would it have things like inspection reports? Yes. Would it have like your management system? Yes. Right? So it's not that hard if you understand the bigger concept of what is a safety case. Like, would it have an audit schedule? That's what they're talking about here. Would it have an audit schedule? Right? Would it have, like a plan for the audit, which is the audit process, like what will be audited? What is emergency plans? And these things are not really new to safety, but when you put them together, it's called a safety report. And there's a requirement, the law is saying that the companies need to have that for the oil and gas industry, right? Examples of specific contents of an offshore safety case. So the name and address of the operator of the installation, look how much I have. A summary of how any safety representatives of that installation was consulted with regards to the revision, review, or preparation of the safety case. A description with suitable diagrams of the main and secondary structure of the installation and its materials and plans. The layout and configuration of the plant, the connection to any pipeline or installation, as wells connected or to be connected to the installation. So any wells, and that is like a flow well we're talking about, right? Sorry, my mistake here. So any wells, like a well that, I don't know if you know those things are oil well, what a manifold system is, a lot of lines that come into one place is called a manifold. But all of those things that would be your diagrams, and if you want to think about like that, like your blueprints, right? For those of us who know something called a PNID, a process and instrumentation diagram. But your blueprints then, the layout of the premises, right? That should be in the safety report as well, or safety case, or what they call it. The maximum number of persons expected on the installation at any time and for whom accommodation is provided, right? Let's see again, past paper, safety case documents offshore and safety report documents onshore contain similar information. Identify these similar information requirements. And so safety case documents offshore and safety documents onshore contain similar information. Again, you could pull it from this slide. You could just go and research it a bit. I could just brainstorm it, but you had to put it in a sentence, right? So like the policy for preventing major accidents, that could be for both onshore and offshore. Risk assessments, onshore, offshore. Emergency planning, onshore, offshore. What again? Could you all remember one from the slide? What do you think is another document that should be in a report? Like what this case file that they're talking about is now?
I'm gonna take a stab at it. Process description.
Okay, a
Would that
description.
be one?
Anybody else remember what I just said? Anybody remember like what I just said? Like would you have drawings and would you have those kind of
Yes.
things?
Yeah,
Yeah,
PNIDs and
blueprint.
things.
Yeah,
Yeah.
yeah, okay, good, right? Excellent, excellent, excellent. Let me see. Okay, good. Let's move on. So outline the reasons for using these documents. You may have to put some thought to that, but the reason for risk assessment is what? To control the risk. The reason for policies to have a goal. The reason for the emergency plan is that you have a contingency plan in place, right? It isn't that hard if you put your mind to it, folks, right? But like I said, I have inundated the past paper with lots of the PowerPoint with lots of past papers. But you should try them, right? You should try them and let me see them on a weekly basis. Then I was telling you all that. But we can't force you all, but that is what you should do, right? These questions don't really take that long, right, to get done. It's not like the open book exam that like this shouldn't take you more than half an hour. So like the homework exam is long, and if even you're doing homework self, it's long. But these questions are not very long anyway, right? All right, moving along, moving along, moving along. All right, so that's it, it's done. Okay, so we'll have to change slides, right? Thank goodness I actually did send the other one today, right? So hopefully this is the correct one as opening here. It doesn't look like it. Oh, I think it's this one. I think it's this one.
So I have a question to ask you.
Sure, sure, yeah.
How much slide it have on this
Wow, that's a good question. Here, what I do, right? And I did it for process safety too. So those who know me know this about me. I give PowerPoints to a certain point, and then knowing that you have the book, I go from the book. The reason is that, well, some of y'all know the reason, right? One of the reasons is like, to me, if the lecturer doesn't use the book, people don't open the book. Like right now, we're not using the book, but I kind of just pointing out the things, right? So there's a couple more then, right? There's a couple more. This one is 91 slides, right? There's a couple more. But eventually, like when we reach somewhere in chapter 4, it's going to kind of boil down then a bit, right? To more using the book. And like I said, the sole reason for that is because there is a textbook and you spend money for it, right? So I have realized like if we just you know, like use the slides then, people get the idea that the book is not important, but I do think a book is important. It's just that we don't let you all to your own devices then. So somewhere down the line, I'll cut off the PowerPoints and we're just going to use the book. Of course, you need to come for your book. Like I said, they are here, right? They are here anyway, right? All right, we're moving on. Let's take this one. I would have to sit down and check because what I might have them in a folder. I know it's probably more than like 5, 6, 7, and all of these are very long. Look at the number of slides, right? Like one of these lasts very long anyway, right? At least you're doing twice a week, so it is kind of going a bit fast, which is what I saw today. When I saw today, because Sunday we started one, and then today we finish it because we see all twice a week anyway, right? So this one, element 2, if I could hold it up in the book, speaking of book, you'd see here we have well, that's the name of the element, right? So hydrocarbon process safety, that's the heading there. And then we look at the learning outcomes. The learning outcomes we have is things like contractor management. You see that there, contractor management. If you look at the first point, this point is on the syllabus, not the textbook. The syllabus says you need to explain the principles of assessing and managing contractors, including the role of parties involved, outline the tools, standards, measures, measurement, competency, requirement, and controls applicable, watch it, to process plant or process safety management, right? The heading is, of course, what I told you. In the oil and gas industry, explain the role and purpose. That's supposed to be, I think this man head is in the way. So this is my thing here. This is supposed to be permit to work, right? So the character kind of took that there, right? I don't think we reached so far. It's about 5 to 7. We may just reach about 2.2. And we could probably wrap this up on Sunday as well. But it's 90 something slides. So it may still be the whole Sunday. Look how much more it have again, right? We wouldn't reach 2.4 and 2.5 and 2.6 tonight. This is definitely going to be Sunday. Maybe from 2.3 is going to be Sunday, right? So the first thing, explain the principles of assessing and managing contractors, including the roles of parties involved. So contractor management, I don't know if you want me to explain, to be honest with you all. I guess we could read a couple and then explain, right? For those of us who are new, right? So there are many categories of contract laborers may be present at a job site. Such workers may actually operate the facility or do only a particular aspect of a job because they have specialized knowledge or skills. Others work only for short periods when there is a need for increased staff quickly, such as in turnaround operations. Oil and gas management includes special provisions for contractors and the employees to emphasize the importance of everyone taking care that they do nothing to endanger those working nearby who may work for another employer. Contractor management third party. So may include maintenance contractors, certified gas testing contractors, safety contractors who may work for a subcontractor, hot work contractors, vessel and diving service contractors, work on drilling and exploration rigs. And you could think of any other contractors, right? There's like so much different contractors on a site. So contractors must take ownership of the work and should plan, manage, and monitor to ensure work is without risk, must provide adequate levels of information, training, supervision to workers about risk and control measures of the job. Contractors and management should operate to achieve the health and safety and welfare of all involved in the work. Contractor ownership is implied within Section 3.1 of the HSW Act 1974. And Section 3 is about contractors anyway, right? Contractor ownership can be achieved by ensuring that hazards at work have been identified and that measures have been taken to reduce the risk. Supervision by client to ensure that subcontractors follow the rules of the installation, ensuring that subcontractors, workers who to report or contract is and the means of the contract, right? So subcontractors, like if you're working under a contract, they have to know the terms of the contract as well. Ensuring that procedures are in place to allow coordination for working safely between contractors, often kind of difficult to do. A major cause of many accidents at work is poor communication amongst those contractors. Contractors must be included in all health and safety procedures of the operation. Induction training must be carried out at each onshore and offshore installation. Contractors should be made aware of the consequences of failing to comply with the owner's or the client requirement for safe work. Contractor ownership, there's a guidance, right? HSG 159. For those who don't know what that means, there's a book for it there. This is an extract from a book, right? So contractor management planning, define the job, identify the hazards of the job, assess the risk, eliminate and reduce the risk, specify health and safety conditions, discuss with contractors if selected, the risk then. Step 2, choosing a contractor. What safety and technical competence is needed? How much years experience? Are they certified? Ask questions, get evidence, go through information about the job and the site, including site rules, ask for a safety and method statement, decide whether subcontracting is acceptable. If so, how will health and safety be ensured? Step 3, contractors working on a site. All contractors must sign in and out, name a site contract, reinforce health and safety information and site rules, check the job, and allow the work to begin. This is all extract from the book, right? Step 4, keeping a check, assess the degree of this is actually contact needed, right? How is the job going as planned? Is the contractor working safely and as agreed? Any incidents, any changes in personnel, any special arrangements required, right? So I think that second point would have been name a site contact, right? So like in the UK, I think they have a name for a person like on a contractor site. The name of the person is the principal designer. But I guess they'd have to name the person. Like when they say name, I don't think there's a position. They will have to put a name like, Frank Henry or something as the site contact. But in a construction site in the UK, there's a law for that. That person is known as as a principal designer. Reviewing the work, review the job and contractor. How effective was your planning? How did the contractor perform? How did the job go? And any lessons learned, etc. Right? So contractor responsibilities to client. A handover comes at the end of the project to install, construct, or modify an asset. It usually involves the client formally accepting the asset, the work area, and relevant information from the contractor. The handover process should ensure that the client is confident that the new asset is ready and safe for use, and they are able to operate, manage, and maintain it. Contractor responsibilities to clients. So this is once a job is finished. So they need to give the name and details of duty holders involved with the project, any design calculations and specification that they perform. You could think of whatever, right? Like tank testing, the whatever they would have done then, right? Whatever the contractor would have worked on, that have to be handed back to the client. As installed or as built drawings, manufacturer data sheet and declaration of conformity, operation and maintenance instructions, commissioning test results, records of inspection or test witnessing, details of any training or instructions delivered. Contractor responsibility to client. Written schemes of examination for pressure systems should be given back to the client. New or revised arrangement and risk assessment for using, maintaining, or managing the asset must be given to the client. Maintenance detail, any third-party approval, fire, insurance, keys. If it's something that they had built and there's a warehouse and there's something with a key, a lock, all of those are given back to the client, right? So safe shift handover in the oil and gas industry are everyday routine processes with proven workflows, instructions, and safety rules. The goal is the reliable and complete transmission of all relevant information needed by the subsequent team to continue safe or working safely or to work safely, right? Efficiency mean effective communication and zero accidents. Effective communication is best done in a two-way system with both participants taking joint responsibility. Participants, despite being from different technical backgrounds who are technically astute, must be effective communicators. Handover meetings are usually formal and structured. Many experts recommend discussing the various topics in order of relevance to take into account the falling attention span of the staff involved, especially when working 12-hour shifts, identifying the criteria for simple and high-risk handovers and defining suitable sequence for both items. Um, I guess I could explain because the reading is just going fast, right? So anyway, a shift handover comes, at the end of a shift. I think the simplest way to put this is that to do a proper shift handover, you need a variety of methods to hand over the shift. And one of them is face-to-face, another one is written, and another one is direct observation. I do think you need all three. That's the meaning of diversity or redundancy in the shift handover process that the incoming shift and the outgoing shift then, they sort of meet and talk face to face, fill out a form if there's anything. This is called a shift handover form. If there's anything that happened in your shift, and then if something did happen, there's a physical demonstration of it. So then if you want to kind of just simplify all of that, right? A shift handover is best done by using a variety of methods, face-to-face, written, as well as a physical demonstration, right? Um, I mean, like what could be shared in a handover is anything that happened, right? So maintenance, any problems that happen overnight or on your shift, right? All of those things are things that you talk about in your shift handover. I'm gonna try to put on back the AC, right? For a couple of minutes anyway, right? Any questions, anybody so far on this? If you all are wrong there still.
No, sir.
Okay.
No question so far.
Okay, let me see. Thinking of an exam question, but I can't think of what. I think all of this is the same thing. All of this is just like the run up then. All of these things are what I mean run up is like talking about what a safe shift handover is, right? Every second accidents or incidents in the industry is due to communication errors during shift change. Like this is not really a question, Alice. I was thinking here. In 4 or 5 cases studied, written notes were in part at the root cause of the accident because they were either misunderstood during the shift handover or simply not passed along at all. Let me put on back the cover, right? Understanding the hazards of a safe handover. Not enough time allowed for safe shift handover, especially where workers may have worked a 12-hour shift. No formal safe shift handover meeting is held, which is, of course, not what's supposed to happen, right? Off-going or oncoming members failing to attend the shift handover meeting. You come late or you're in the washroom, right? Or you think it's not for you. Outgoing shift wanting to get off because you have been working for 12 hours. God forbid if you made a 12 by 12, a 24-hour shift, right? Because somebody didn't come out. Conflict between the shift, right? You have my batch and your batch. We have our team and your team, right? So, we do like that person in that day shift or whatever, right? So conflict between the shifts. How much the off-going shift actually achieve, and was that communicated to the incoming shift anyway, right? Again, those of us who know about shift work sometimes, like the night shift doesn't do as much as we would want them to do. A lot of people like to work night because, you could take a good sleep, right? But, it's all about the money, right? And so how much was really achieved if, you had X to do, etc., right?
Sir,
Understanding the hazards, yeah, go ahead.
what recommended for like doing a handover shift for 12
Yeah,
hours? They don't wait exactly for that 12 hours to complete now. You look to come in
shift
at least an
handover.
hour before so you have hands-on on the work and you get a better communication with the workers and the super. You got
I like
understand
that.
what's taking
But I
place.
like how you say hands-on because that falls into what is the physical demonstration, right? So very good. Very good because if you wait for the 12 hours, whatever, 24 hours, people may be sleepy and they probably will fall asleep. And if they're in your meeting, they're probably not hearing what you're saying anyway, right? So that's a good idea. Like I said, it is what they said was redundancy or diversity, which is face-to-face, written as well as physical demonstration. A lot of companies do it like that. They go around and they sort of do like a physical demonstration, physically talking to the workers, etc. Then, right? But we have seen, and you all have seen, safe shift handover meetings where people come and sleep away in the meeting, and no fault of theirs. It's just what it is anyway. All right. Let's go again. So a tendency for I think we read this already. Okay, a tendency for the off-going shift to leave work they didn't want to do. Yeah, leave it for the guys and them in the morning shift. And likewise, the morning shift for the day shift does the same thing to the night shift, right? Failure to meet face to face to discuss it, and this is what we're saying shouldn't happen, which is why they say it's a hazard, right? Failure to use adequate written communication. So you talk, but you didn't fill out the form, right? Lack of continuity between contractors, a lack of proper record keeping. Again, that safe shift handover form is a critical document. It must be kept. Failure to hand over permit to work properly. And again, that has been the cause of many accidents throughout history as well, which is what we're seeing here. Examples of the pitfall from not following a structured approach for safe shift handover are evident throughout recent history. Case in point, on July 6, 1988, a large fire explosion on the Piper Alpha offshore platform killed 165, some say 167, and completely destroyed the facility. Right? Process safety management. That means we finished 2.1. Remember, I told you in the beginning, we wouldn't reach 2.2, but we might reach 2.1, right? You want to see what the book had in it? One short paragraph, safe shift handover. What it is. That's all the book had on safe shift handover. We had way much more than that. By the way, it's the same thing. The hazards. Listen to it. And I'll show you what I have on this slide, right? The hazards is the same thing. Not enough time. No formal shift handover, which is the second point. Incoming shift seeing problems ahead and wanting to get on with them. Conflict between shift. A tendency for the off-going shift to leave work they didn't want to do. So it's the same thing. We had so much more on shift handover, sorry, right? But like I said, the course is not a very difficult course, but you need to kind of pick your poison. If it's the slides, it's the same thing. I'm telling you, pick your book and start studying one or two. Or just like those of us in the field, you could probably think about that. And like that to me wasn't something to study. right? Like, what is the hazards of safe shift handover? Like, what could go wrong then? And we said it, people could sleep, people could be tired, fatigue, right? It could not have been written down, it could not have been followed up on, there was no physical demonstration. That's a big one. So you talk and you're right, but then you did say, okay, the temperature gauge in the night shift seemed to be saying the wrong temperature, but nobody went and checked and see. You just take a record of it, right? You're sleepy, the incoming shift probably working in 20 days to 10 days or 15 days or 30 days, so 12 hours back to back, right? So yeah, they say, okay, well, the temperature gauge, yeah, we take a note of it, but they already see how bad it was now. In the night, pressure increase, temperature increase, and you have an explosion, right? So you can think of these things. And by reading it, again, one of the things I used to do for those who know the story, I used to print my handout. And anywhere I go, folks who are here, those of us who are working, Stephen, and those of us who are out in the plant and stuff, right? I used to carry my handout. So sometimes people may feel like the book is a bit bulky. Of course, it isn't that bulky, right? It isn't that bulky. But to me, PowerPoints were like just something to crumple up now. So like I think I told you this before, I'm in the bank, I'm reading out my stuff, right? If I'm waiting somewhere, I'm reading out my stuff. I might get the whole PowerPoint read, but I'm gonna read 3 slides or 3 pages, and that 3 pages have 6 slides on it. So that's 18 slides I read, right? And that's what I do. That's what we used to study long time before the pandemic, right? Especially those of us who were working and studying at the same time. And I could tell all the stories. Some of you all know it. I used to be on a piece of pipe. You sit down, you have your lunch for 10 minutes and you sit down in, wherever the machine shop was. And I would run through my notes. Ain't nobody doing you nothing. Where I eat for a whole hour for you, to take a whole hour to eat. Right? All right. 2.2. Looking at the time. 2.2 is only 2 pages long in the book. 2.2 focuses, the heading is actually PSM, look at that. Same thing you're looking at, Process Safety Management is the heading. Same thing on the slide. So you're missing nothing, but please come for your book. Remember, I don't want it here too, right? If you're spending money, so we bought your books for you. All right, we go in. Controls used in the PSM industry for fire prevention includes the Dow Fire and Explosion Hazard Index, developed by ICI in 1979. Now, the only reason I probably put that there is because it's something I saw on the syllabus, right? Used in the design of plant layout, it divides a plant into units and analysis, right? Calculate the hazard of fire and explosion in each unit from chemical substances. Both indices, fire and explosion, give a realistic value to the risk of each individual process. So you may want to kind of blow this up. I don't ever expect them to do something like this and to give you something like this because the questions are not so much a mark. So let me just bring this up here, right? You could probably print that as a whole calculation or a whole slide, right? The Dow Fire and Explosion Hazard Index developed by ICI. Um, you could have a read of it. Definitely, this is something from our degree class anyway. I don't see them. These are the degree levels, like 20 marks, right? I don't see them asking you to calculate, anything like that anyway, right? So one of the ways you can learn too is like looking at a video, right? Possibly the question here is 2 marks. Possibly the question is 2 marks. What is the use of, like the Dow Fire and Explosion Hazard Index? Using the designer plant layout, it divides a plant into smaller layout and it kind of calculate what's the probability of a fire happening in each of those units anyway. So the point of this is that you can be better prepared and prevent a fire anyway, right? So the controls available in PSM includes spacing of operating plant. So this is how you can get rid of some of those things. Positioning and protection of control room and critical equipment. Specifically occupied building assessment, temporary refuge offshore, and the critical safety systems associated with temporary refuge, integrity, fire resistance, blast resistance, etc. Right? HVAC, access to evacuation means, etc., heating, ventilation, and air conditioning system. So I think what they're trying to say is that, well, these are examples, right? The HVAC is like an example of a system that you want to kind of control, right? So we could be saying here that they have, if you look at it carefully, it's not about, heating and lighting, but it's really access to evacuation means is the control, right? So the hazard of a fire and explosion, if you're in one of those confined areas, then do you have suitable emergency rescue, right? When they talk about temporary refuge on an offshore platform, right? So do you have, like a way out of that? Does it have a certain amount of fire resistance? I could talk about these in it, but I don't know how much you have to know. Does it have a certain blast resistance? For those who do know, refuge rooms then, which is a place you go in the event of a fire and explosion, is meant to withstand a fire for a certain number of time. They could actually calculate that, like 30 minutes, 20 minutes, etc. Right? They have certain things you can put on the door, like intumescent materials, fire retardants, and they are meant to give a certain amount of integrity. They actually call integrity like stability over integrity. There's a formula for it. I say that again, right? These are not just words. These are not just words. The safety of a refuge room could be judged over like a formula, right? Like stability over integrity. And you get like a figure like 20 minutes. So a refuge room, which is a room designed to withstand a fire or explosion, would have like a certain figure. That's what they talk about all of these calculations here as well, right? So it'll have like a figure then, but we could stick to something meaningful instead of like, point one or point two. We could stick to saying the refuge room have stability and integrity for 30 minutes. Meaning, in the 30 minutes that you're there, you should be rescued. Because a refuge room is not meant to live on an offshore platform. It's meant to go there to get rescued, right? Management of change, I think, is what this was all about, right? The next big thing here in 2.2. Let me just kind of cast my eyes on the time. So to properly manage change to process chemicals, technology, equipment, and facilities, one must define what is meant by change. In this process safety management standard, change include all modifications, equipment, procedures, raw materials, and processing conditions other than those that would have been required by normal replacement, right? Other than what would have been required by normal replacement. So management of change covers such as changes in process technology and changes in equipment and instrumentation. Changes in process technology can result from changes in production rates, experimentation. When you found out there's a better rate, you could set your pumps at, the RPMs, equipment unavailability, new equipment, and changes in operating conditions to improve yield or quantity. Temporary changes have caused a number of catastrophes over the years, and employers need to establish ways to detect temporary changes as well as those that are permanent. And the answer is the management of change form. That's the way, right? Temporary changes are subject to the management of change provisions. In addition, the management of change procedures are used to ensure that equipment and procedures are returned to the original or design conditions at the end of the temporary change. Proper documentation and review of these changes is invaluable in assuring that the safety and health considerations are being incorporated into the operating procedure and the process. A typical change form should include a description and the purpose of the change, right? So you're changing out equipment, but you can't find the one that you sourced before. So you have to change the type of equipment or the brand that requires a management of change form. And I have a lot more here, right? Safety and health consideration, documentation of changes for the operating procedures, maintenance procedures of what you're going to change, inspection and testing of what you're going to change, electrical classification, training and communication, pre-startup inspection, duration if a temporary change, approval and authorization. Formal documented system developed to identify required modification. So let me stop, right? Let me stop. Because all you're trying to tell you is whatever you're changing, you need to document it. So if you modify something, follow the MOC form, right? If something changed with a hazard, follow the MOC form. All changes must be authorized by competent persons, and of course, it must be captured, right? So all changes to process plan. Anything you change anything that wasn't a normal replacement, like it wasn't normal inspection, or it wasn't like the end of the life of the product anyway, well then that doesn't need a MOC form. But if something happened, right? You have a battery, you have a 2-year warranty, and after 1.5 years it stopped. Well, that may require you're going to change the battery now from whatever brand you was using. that may require a change of supplier. Say you need to follow out like a MOC form. And let's use some simple examples, right? You're going to change an alarm, you're going to change a level gauge, you're going to change the flow rate, yeah, pump rate, RPMs. Those of us who know anything about those things. So maybe via testing in the machine shop, you realize that the RPM of the pump, which is the revolutions per minute, could give you a better yield if you probably slow it down a bit and you just let it run at a normal pace, right? So instead of like it running pretty fast, you just slow it down, 60 revolutions per minute, which is not bad. 60 revolutions per minute. Some may go higher, some pumps lower. But then you realize that if you change the RPMs, you're burning out the pump. You had to change rod, you had to change, seal. So just let it run. It could, and for those, so anybody know what I'm talking about? These pumps could control the flow rate into like a tank, into a vessel, right? So like it may be that the tank filling too fast. When I say filling too fast, yes, could be oil, could be whatever, but the trucks, the delivery trucks, right, come in, like they're not coming that fast. The time it takes to go to tank farm and come back is about an hour. So why are we running the pump so fast, right? Let the pump just run normal, less stress on the pump. So if you're changing the RPMs, what I'm saying, that requires a MOC form. You have to see the purpose of the change. It's going to be more economical. It's going to reduce the hazard. It's going to reduce probably driving hazards as well. The driver having to speed back to your facility, right? It's going to extend the life of the pump. We are probably going to say that it's more running to the manufacturer's instruction now as opposed to running for production, right?
So
So I think I'll go, yeah, go ahead. Anybody, go ahead.
concerning the pump too, like if you don't follow the manufacturer instruction, the condition of the pump or the environment where the pump is changing, if you're running on a higher RPM, like more decibel it gonna have. It might have more
Yeah,
vibration. All these things condition wise you have to look at too.
true, true. Because they would have put the, for those who don't know what Steve was talking about, all machines have it have the noise and the vibration limit printed on it, right? But I guess they would have set that at a particular RPM. But companies like production are fill it tank, because the more oil you sell, the more money the company gets. Of course, that's my background anyway, right? For lease companies now. But like I said, if you're doing that, then you're running the pump and then the pump have to service, which is probably not bad for some companies. But the thing is, if you have to buy a pump, one of those pump and jacks or pumps, whatever you all call it, is 100,000 and over, right? Lufkin. And I given you prices 10 years ago, so who knows the price of those things now, right? So the point here is that a management of change form needs to be filled out. So I think I'll just read out this last one here. And then we could call it just maybe 2 slides and look the topic change in here, so we could probably stop, right? This could be a typical heading for a permit to work. Sorry, not permit to work, I read in the next slide ahead of time, right? A typical heading for like a MOC form. So we have who is the MOC owner, who it is recommended to change, who is the person responsibility for authorization. Now, these headings could change because looking at it, I think I kind of duplicated the heading, but you could put your own heading. You can say, who is the MOC owner? What's the implication of the change? What's the consequences of that? What are the controls, right? You could put all of that and you could download an MOC form for yourself, right? I don't think, let's check and see. You could just go on Google, right? Remember, not everything, yes, you have a book or whatever, but life has changed and the world has changed compared to a long time anyway, right? The book doesn't have an example of a form either, right? But they do have the contents of the MOC form either, which is why I probably didn't stress on it, because it's even not in the syllabus. We don't go down that way then, right? But if you want to see a MOC form, maybe you could download one, just go on Google and download the MOC form. The point is like this, but you could put your headings then, right? Who was the owner? Who proposed the change? What's the implication of the change? What's the hazard? What's the risk? How do you control it when you review the MOC form, right? So I think we had to stop. Let me see if there's any more. I can read this one, right? Let's read these two, right? So management of chain rule and responsibility. So task requirement to be matched to the personnel skill set and the competence of such persons. If a gap exists, this can be used as scheduling further training. Changes should be in phases. So all of this is just general statements, right? A change proposed document should be used. This would identify those who can authorize the change, ensure that plan changes are within all operational safe limits. Yeah, if you're making a change, you got to make sure that what you're doing not upsetting another parameter now. Like how Stephen mentioned noise. If you're increasing the RPMs, well, but what's the noise level? Like what the law says about noise, 80 decibels. So then how does that affect that? Right? So that's the only implications of the change. If you want to remember any other word, implication of your change, I've called about five. Who is the MOC owner? Not as if it is in the syllabus, as I was saying. I'm just saying how to try to understand it, right? Who is the MOC owner? Was the proposed implication of the change? So would you get higher productivity? But when the noise increase, what's the hazard? What's the risk, right? How do you control it? Like a typical RA, what's the review date and whatever have you on it, right? All of that is part of the MOC form, right? We'll stop here because I really don't know what time it is. Well, as it's minutes to have seven from what I could catch. But I don't. The clock on the wall is not a digital, right? I'll have to check my phone. It's actually 7:25, right? Let me just mark the rule. If I could find where the rule is, I think I have it on the other table because I made it from there. If you come into the office, please call me before to collect your book, right? Oh Lord, I think I'm the wrong file. This is the one. This is the one for Guyana. Right, for that's in Guyana. So no register. Right. Next week if you're all here, right? Oh, so are you all here next week? Next week. Next week is Wednesday. I am in Trinidad next week, Wednesday, right? But I'm leaving on Tuesday to get a job done in Guyana. So next week, Wednesday's class. Well, Sunday's class is normal. And next week, Wednesday. Oh, this is a new pen, right? Next week, Wednesday is also class. I'll have to let you know what's going on the following Wednesday, though, right? I haven't really checked it to see, and I don't want to check it now. But you could probably remind me on um on Wednesday. Sorry, on Sunday, right? You could probably remind me on Sunday just to kind of because it's late already now to see what's happening. I think I'm flying back to Trinidad the following week, but the calendar on the wall is still September, so I don't have the dates in front of me, right? Um, Kyle, let me stop the recording, by the way. Kyle,
Yes, sir.
did we stop the recording already? No, we didn't.